All right, today we're going to be looking at finding vertical asymptotes. At this point, we have already discussed what an asymptote is. So I need somebody to refresh my memory. What did we say an asymptote was? Do you remember?
With a line
Okay, pretty close. It's a line that our graph approaches but doesn't actually touch. Matter of fact, we said there's two of them. We have a horizontal asymptote and we also have a vertical asymptote. What we're going to be looking at today is specifically how do you find it when we're looking for that vertical asymptote. So that's what we're going to concentrate on today. How do you find a vertical asymptote? Now, we are going to be using our calculators today, guys, so I do want you to reset your calculator for me first. So go ahead and go through the resetting process. Do the second plus 712 point. Second plus 712. Reset them so that we don't have any trouble while we're graphing. Second plus 712. All right, now that you got that taken care of, let's go ahead and get started here. All right, so you'll notice up at the top it says to consider the function y equals 2x over x minus 4, and we're going to complete the table and sketch the graph of that function. So what I need you to do first is go to y equals on your calculator. Now I know some people, when you're typing in that function 2x over x minus 4, there's two different ways that we can do it. And I want everybody to go ahead and do it the same way. So everybody look up here first. Make sure you're typing it in. I want it typed in so that we have it looking exactly like what we see on our worksheet. I want to see that fraction there. So for those of you that forgot how to do it, we go to alpha, which is the green button, and then y equals. This little screen here should pop up. The very first choice you see there is n divided by d, numerator over a denominator. Go ahead and select that one because that's what we have here, is a numerator and a denominator. And then you get this here. So up at the top, we're going to type in the numerator, which in our case is the 2x. So let's type in 2x. Hit your down arrow key so we can type in the denominator, and that denominator is an x minus 4. There's the x minus 4. And I'm just going to hit the right arrow key just so that I can see the fraction, 2x over x minus 4. Everybody got it typed in just like I have it. All right, what we're going to do first is we're going to complete the table. So let's go to second graph so we can take a look at the table. What I want you to do is fill out the table on your handout here. I want you to fill in the y values when the x values are 1, 2, 3, 4, 5, 6, and 7. So go ahead and fill those out for me real quick, and then we'll talk about it. 1, 2, 3, 4, 5, 6, and 7. All right, so now that you got those filled out, right next to 1 you had a negative 2/3. Next to 2 you had a negative 2. Next to 3 you had negative 6. Next to 4, what do you see next to 4? Error. So write that down. Error. Next to 5 was a 10. Next to 6 was 6. And what did you see right next to 7? What's that? 14 over 3. 14/3. So this is what we have here. Now I want to extend that table, and I want to look at 3.5, 3.8, 3.9, and so on. So how am I going to get to see those numbers in my table? Right now it's not going to show up. Does anybody remember how we can get these to show up in our table? How can I get the 3.5, 3.8, 3.9? Second window. And right here, if we go down to where the little triangle table, we can tell it to count by anything we want. Right now it's counting by 1. So I'm going to change that to 10. So put 0.1. Go back to your table. And now if we scroll down enough, we should be able to see that 3.5, 3.8, and so on and so on. So go down until you find 3.8, 3.9, 4.1, and so on and so on. So let's see what values we get. All right, 3.5. Anybody got there yet? 3.5. What do you see next to 3.5? Negative 14. Next to 3.8, you see negative 38. Next to 3.9, you see a negative 78. Now let me stop right there real quick. Notice what's happening. Notice the closer I'm getting, to that 4, or to that error that I have here, what are you noticing about the y values as I'm getting closer and closer and closer to that 4? Are they getting bigger or are they getting smaller?
Bigger.
Smaller.
Smaller. They're negative numbers, guys. So negative 14, negative 38, negative 78, those numbers are getting smaller, smaller, and smaller. The closer I get, the smaller and smaller those values get. Let's go ahead and 4.1. What do you see next to 4.1? 82. Next to 4.2, you see a 42, and next to 18, or next to 4.5, you see a 18. Again, I want to point out, notice what's happening here. Notice the closer and closer and closer I get to that 4 again, notice what's happening to these y values here. At 18, 42, and 82, what's happening the closer I get to that 4? They're getting bigger. Notice the y values are getting bigger. All right. So we've got our table filled out. Let's go ahead and take a look and see what the graph looks like. So let's come over here and let's start plotting these points. 1, negative 2/3. Let's start there. 1, negative 2/3 will be somewhere right about here. Kind of small, so just kind of do your best. 2, negative 2 is the next ordered pair, which would be right about there. 3, negative 6 is the next ordered pair. 4 error. Can you graph 4 error? Is there such a thing? Nope, so skip over that one. 5, 10 is the next ordered pair, so let's find 5, 10, which is way up here. 6, 6, right there. And 7 and 14/3. Well, I know where 7 is, but what the heck is 14/3? Well, what is 14/3 as a decimal? Put that in your calculator. What is 14/3 as a decimal? What is 14 divided by 3? 4.6. So we're looking for 7 and then 4.6. So we're looking somewhere right about there. So I'm going to go ahead and connect these dots. So I'm going to get something like this and something like this over here. This is the graph of our rational function. Now remember the other day we talked about having 2 lines that we come close to that don't touch. We call those asymptotes. There's 2 of them. We have a horizontal and a vertical. However, right now we're looking specifically at the vertical line. Now notice over here to the right it says, how can you tell that an asymptote occurs at x equals 4? So in other words, I know this is the line that I'm going to get really close to but not touch. How do we know that? I'll give you a hint. Look at the table. How do we know that it's going to occur at 4? Yeah, it has an error. So write that down for me. We can tell that that asymptote occurs at x equals 4 because of the error. Now right below the graph it says what happens as you plug in numbers closer and closer to that x equals 4, to that vertical line. Well, I kind of pointed that out over here. We notice they either getting smaller or larger, depending on from what side we're coming. Okay, so they either get larger or small. They get very large or very small. They get very large or very small. Now, right below that, it says, what kind of asymptote is this? This line that I just drew here, is that the vertical asymptote or the horizontal asymptote? Vertical. So write that down. This is the vertical asymptote. It's the line that goes up and down. That's the one we're going to be looking at today. That's what we're going to concentrate on. All right, so right below that, you got a couple of examples that we're going to be looking at. Let me go ahead and blow this up. There it is. So if we take a look at number 1, the first thing we're going to do is fill out the table. Once we've got the table filled out, we'll go ahead and identify our vertical asymptote. So go to your calculators again, go to y equals, and type in x minus 4 divided by x minus 2. Type in exactly like I showed you earlier using the alpha y equals. Type it in as a fraction. Once you got it typed in, you're going to go to your table. And in your table, you're going to be looking for the y values when the x values are 0, 2, 4, and 6. Now remember, earlier we did change our table so that it counted by tenths. If that's bugging and you want to change it, just do the same thing we did earlier. Go to second window, change that 0.1 to a 1. That way all you see is the whole numbers. All right, so what do you see next to 0? 2. What do you see next to 2? Error. Next to 4 you see a 0. And next to 6 you see a 1/2 or 0.5, however you want to write, same thing. Now that you have the table filled out, I want to know what is the vertical asymptote. That's what the VA stands for. The vertical asymptote is that vertical line. And you write the equation for a vertical line as x equals some number. So what's the number in this particular case? 2. And how do we know it's 2? Well, because that's where the error occurs. So again, vertical asymptote for number 1 is x equals 2. That's that line that we're going to come close to, but not touch. Let's try that again with number 2. Again, go to your calculator again for me. Go to y equals, type in x plus 8 over x minus 6. Once you got it typed in, we're going to go to our table and find the y values when the x values are 2, 4, 6, and 8. It looks like some of you are there, so what do you see next to 2? Negative 5 over 2. What do you see next to 4? Negative 6. Next to 6 you see error. And next to 8 you see 8. So now that you have your table filled out, now you can write your vertical asymptote. And that vertical asymptote is always written as x equals some number. In this particular case, that number is x equals to a 6. That's where the error occurs, which means that's where the vertical asymptote is. All right, let's go ahead and do the same thing again for number 3. X plus 1 over x plus 3. Let's get this table filled out. All right, what do you see next to negative 3? Error. Next to negative 1, you see 0. Next to 1, 1/2. And next to 3, 2/3. Now that you have your table filled out, you can go ahead and write the vertical asymptote. And that vertical asymptote is x equals to a what? Negative 3. This is our vertical asymptote. All right, I want you to go ahead and do the same thing for 4, 5, 6, and 7 for me, and then we'll take a look at them here in a second. Go ahead and put those in your calculator. Fill out all the tables. And then give me the vertical asymptote. Give you a couple of minutes. Number 7 is going to be a little different, guys. Okay, looks like most of you are done or just about done, so we'll go ahead and start taking a look at it. Number 4 in your table. Where did the error occur in your table for number 4? 6. Right next to 6 is where you found the error, which means your vertical asymptote was x equals to a 6. What about for number 5? Where was the error on number 5? Right next to the negative 1.5, which means your vertical asymptote should have been x equals a negative 1.5. Number 6, where was the error on number 6? Next to which number? Next to negative 4, which means your vertical asymptote was x equals to a negative 4. Now number 7, like I said, was a little different here. Where did you find the error on number 7? Right next to negative 2, but you also saw another one next to the positive 2, okay? Which means we have 2 vertical asymptotes. So you should have been writing down 2 equations. We have x equals to a negative 2, but we also have x equals to a positive 2. And so this time there are 2 lines that we're going to come close to but not actually touch. All right, so 2 of them on that one because we had 2 errors. Now later on when you get into pre-cal, you may have 3 vertical asymptotes. You may have 4. Right now we're going to stick to no more than 2. That's what we're going to stick. All right, so these are all the vertical asymptotes. Now before I move on, we also talked about domain. What's domain? Is that the x or is that the y? X. The domain of all of these graphs are all numbers except for one number. All numbers except for 1. So if we look at this first one here, number 1, the domain of that graph are all the numbers except for one x value. There's only one x value that I'm not going to use in that graph. What is it? 2. It's the same thing as my vertical asymptote. So I want you to write this down for me on your paper. The domain for number 1 is all the numbers except for a 2. And the way we wrote it was x does not equal to a 2. What about the domain for number 2? Well, it's the same thing. All the values are used except for 1. And the value that's not used for x is a 6. Number 3. Again, the domain for that graph is all numbers except for 1. And that one number we're not going to use for x is a negative 3. Remember, that's that number we're getting close to, but we're not actually going to get it. What would be the domain for number 4? X does not equal what? 6. Number 5. What is the domain? X does not equal a negative 1.5. Number 6, the domain here would be x values except for negative 4. And number 7, again, a little different here. What's the domain for that? All the numbers except for what? Except for negative 2 and positive 2. So there's 2 numbers I'm not going to use on number 7, and that's 2 and negative 2. So here we go. Now I'm going to take a little shortcut, and we're going to say x cannot be 2 and negative 2. So I'm going to put plus and minus 2. So those are the 2 values x cannot be. That's where our 2 vertical asymptotes occur. All right, so if we look over here, A. A says, are these asymptotes related to the numerator or the denominator? I think we talked about this the other day. If you look at these vertical asymptotes that we came up with, look at these things right here. Notice how there's a relationship between those vertical asymptotes and the denominator. What did we say about that the other day? What did we notice? They're opposites. Okay, so we're going to take a closer look at that in a minute. But right here it says, are these asymptotes related to the numerator or the denominator? Well, as you can see here, it's the denominator. Is where the relationship occurs. Now, number 1, 2, and 3, yes, it's just the opposite. But if you look at 4, 5, and 6, look what we have here. Are we just doing the opposite here? Is it just the opposite? No. A little more complicated than that. So down here at the bottom, B, where it says, how can the asymptotes be determined? Using this part of the expression. In other words, how can we use the denominator to find that vertical asymptote? Well, here's what we're going to do. We're going to set the denominator equal to 0 and solve. We're going to take the denominators, set them equal to 0, and solve. So let me show you a couple of examples. Let's start with number 4. Number 4. If I take the denominator, which is 2x minus 12, and I set it equal to 0, I want you to notice something here. If I solve for x, the first thing I would have to do is add 12 to the 0. And 0 plus 12 is 12, of course. Then what would you do to solve for x? Divide by 2. And what's 12 divided by 2? 6. Notice what my answer is here, and notice what I got over here. Notice it's the same thing. Look at number 5. 2x plus 3. If I set that equal to 0, look what's going to happen. First, I subtract 3. So 0 minus 3 is a negative 3. Then what? Divide by 2. And what's a negative 3 divided by 2? It's a negative 1.5. So notice it's the same thing I have right here. Look at number 6. If I take the 0.5x plus 2, set it equal to 0, look what happens. Subtract 2. Take negative 2 and divide it by a 0.5. Guess what I'm going to get? Negative 4. Exactly like what I have right here. So all we're doing is taking the denominator, setting it equal to 0, and solving. Now look at number 7. A little bit different with number 7. X squared minus 4 equals 0. What do you notice about this equation? What kind of equation is it? What do you call it when there's an x squared in the problem? Not a square root. Quadratic. It's called a quadratic. How many solutions does a quadratic have? 2 solutions. 2 solutions, which is why I have 2 vertical asymptotes. I gave you 3 ways to solve a square, or not a square root, but a quadratic. We had graphing, we had quadratic formula, and we also had factoring. Those are the 3 methods that I showed you guys. Out of those 3, which is the easiest and fastest? Graphing. Everybody graph that for me real quick. X squared minus 4. By the way, remember, before you can graph it, it's got to be equal to 0, which in our case it is. Hey, once you graph it, what exactly are we looking for in that graph? The zeros, or the x-intercepts. And where are those x-intercepts? Negative 2 and positive 2. Okay, so whenever we have a quadratic in our denominator, how many vertical asymptotes are we going to have? 2. Okay, so we have 2 solutions in a quadratic. All right, so that takes us through the notes. We'll take a look at the assignment here in a second.